Hi dear students, today let us study the new topic revisiting irrational numbers. Actually, we have studied about irrational number in our 9th class. Just recollect what is irrational number. Let me tell you. Irrational numbers are those numbers which cannot be expressed in the form of p by q, where p and q are integers and the denominator part, that means q, not equal to 0. Means if the denominator part, anyhow denominator part will not going to become 0 because division by 0 is not possible. So keep that in your mind. The denominator part will not become equal to 0. Okay. And also we have studied that if a number cannot be expressed in the form of p by q, that numbers are categorized as irrational numbers, or in other words we will say surd, S-U-R-D, surd. That's another term for that one. In standard 9 we have studied about how to represent an irrational number on a number line. You have studied different methods in our 9th class, how to locate, right, an irrational number on a number line. How to show it on a number line. That's what we have studied in 9th class. But we haven't studied how to prove that a number is irrational. We know what is irrational number, but we don't know how to prove that one, right? So in our 10th class, in this section, we are going to study something that how to prove that a number is irrational. In other words, we can say the irrationality of numbers is gonna proved in this section. So anyhow in your mind it is there that root 3, root 2, root 5, root 7, these numbers are irrational. Means we cannot take the perfect square out. That's the meaning. So anyhow, as you know that it is irrational, then the question comes, how can you clarify that it's irrational? For this one, we are going to prove it. And this proof is so important because in plenty of board examinations, you can see some of these questions may be repeatedly asked every time, right? Every time they are repeating the same questions. Prove that root 2 is irrational. Prove that root 3 is irrational, like that. And there are some things which we have to know and which we must to know about irrational numbers. See, if a number, already you know, I told you that what are irrational numbers. If you are adding a rational number to an irrational number, that means if you are adding a rational number and an irrational number together, the result will be irrational. If you are subtracting a number from an irrational number, or if you are subtracting an irrational number from a rational number, the answer will be again an irrational number. If you are multiplying a rational number with an irrational number, then also you can see the result will be irrational itself. And if you are dividing a rational number with an irrational number, there also you can see the result is still an irrational number. So keep this much things in your mind because these are the things which we are going to discuss while proving the statement. So this much base should be there inside your mind. Then only you will understand the proof actually. And also there is also one more proof, or there is also one more thing which we have to remind when we are going to study about this proof. Okay, means like right now we are going to discuss about that proof. Listen to the proof very perfectly. The proof states that let p be a prime number. Let p be a prime number, and if p divides a square, then p divides a also, where a is any positive integer. That means if there is a positive integer and if you are taking the square of that positive integer, and if there is a prime number, say it is p, and if this p is divisible, if this p divides a square, definitely this p will divide the root of a square, that means a also. Now let us just imagine a number. Right now I told the statement that if there is a prime number p, if it divides a square, then definitely that prime number will divide a also. I am going to prove that. I am going to give a small example so that very fast you will understand that. See here, just imagine a prime number, say 5. 5 is a prime number. So if 5 divides 5 square, what is the square of 5? It's 25, right? If 5 divides 5 square, then definitely this 5 will divide 5 also. Is that clear? If 5 divides 5 square, 2 is a prime number. Imagine like the 2 is a prime number, right? If 2 divides 100, If 2 divides 100, what is 100? 100 is the square of 10. So if 2 divides 100, then definitely 2 will divide 10 also, isn't it? Now I hope you understood, right? So that's the idea behind this one. If a particular prime number is dividing a square of any number, then definitely this prime number itself can divide the root of that particular number also. That is a statement which you have to understand, because regarding this statement, we are going to use this particular statement to prove the irrationality of numbers. Okay, so first of all, let us get into the question. Going to the next exercise, the very first question. What is the first question? Prove that root 5 is an irrational number. Prove root 5 is irrational. That's what you have to prove. So see, listen to this proof very carefully, because it's a very important topic, and I told you 20 times the same topic was repeated in board exams. So give more seriousness to these things. If you once understood the steps perfectly, how I am going from one step to another, if you understood, you can prove any number. That means you can prove that root 7 is a irrational number. You can prove that root 11 is an irrational number. You can prove that root 13 is an irrational number. You can take any irrational number and you can prove the irrationality of that number. If you understood these steps, means there is an algorithm which we have to follow on. Okay, so now listen to this one. Here, what is our question? We have to prove that root 5 is irrational. Okay, so now let me get into the question. See here, first of all, this proof, see, we cannot directly prove that it is irrational. What is the meaning of irrational? Irrational means it's not rational. It's not rational, because in 9th class we have studied like this, that there are two typical types of numbers. One is what we call rational numbers, another one is called irrational numbers, right? If just imagine, if in a bag is full of real numbers. Okay, you are given a bag full of real numbers, and if I tell you to choose or to pick out all the rational numbers, then you know what will be left inside that bag. As already you have picked all the rational numbers, the only thing which is left inside the bag will be irrational numbers. And in the same case, if I told you to pick out all the rational numbers and pick out all the irrational numbers from the bag, then what is left inside the bag? Definitely nothing will be left. That means irrational number and rational number all together, it forms real numbers. So we can say that if you want to prove that a number is irrational, you have to prove that it is not rational. That's all. That will be much more easier. That's the way which we are going to use right now. So we are going to prove that this is not rational. Okay, that's what we are going to prove. Okay, now getting into the step number 1. First of all, whenever you are getting a question like this, you will write, let us assume to the contrary that root 5 is a rational number. That means we are just assuming that anyhow we have to prove that root 5 is irrational. But what we are assuming, just opposite we are assuming. We are just taking in our mind, or we are going to tell a statement that let it be a rational number. Okay, so that's a statement which we have taken. Let root 5 be a rational number. So you know that any rational number can be expressed as the form P by Q. So here I am going to take, instead of P and Q, I am taking A and B. Okay, it doesn't matter, you can take any letters. It can be M or N, it can be P or Q, it can be A or B. Here I am just taking A and B for the convenience. Okay, now what did I say? Root 5 is a rational number. So next step, therefore there exist A and B such that root 5 is equal to A by B, where A and B are coprimes. That means if you said that root 5 is rational, then definitely you can express it by the form A by B. You can express by the form by numerator by denominator, because it's a rational. That's what you assumed right now. So we are writing, let root 5 is equal to A by B. One more thing is very important, which I wrote on the right hand side. What was it? A and B are coprimes. Now what do you mean by coprime numbers? You know what is prime number, right? What is coprimes? Coprimes means coprimes are those numbers which are having only one as their common factor. If you are taking two numbers, and if two numbers are prime numbers itself and they are having only one common factor, only a single common factor, and that is 1 itself, then those numbers are what we call the coprimes. Did you got the idea? Okay, now that is co-prime numbers. Clear? So here A and B are co-prime. So keep that in your mind that A and B are co-primes. That means inside your mind it should be like this, that for A and B there is only a single common factor, that is 1 itself. Keep this in your mind, okay? Because we are going to come to the next statement. There I will again ask about this particular statement. So keep this in your mind. A and B are having only a single factor as common, and that is 1 itself. Okay, now what did we wrote? Root 5 is equal to A by B. Taking the square roots on both sides, what will happen? In the LHS, root 5 square, what is it? It's 5 itself. 5 is equal to A square by B square, right? Now cross multiply. 5B square is equal to A square. 5B square is equal to A square. What does it mean? It means that 5 divides A square. It means that 5 divides A square, right? 5B square is equal to A square means 5 divides A square, isn't it? Means it may not be that much digestible for you to understand. I will clear it out. See here, 5 is equal to, if 5 into a particular number is equal to 100. 100 means 10 square, right? 5 into a particular number is equal to 10 square. What does it mean? This 10 square and this 5, check out this one. 5 can divide this 10 square. That is the meaning, isn't it? What is the square of 10? It is 100. And this 5 is divisible in 100. 5 can divide this 100. That's the meaning. So hope you understood that. That's why I told you before starting this proof, you have to know something. That's what we told in the initial part of this video. Okay, now you understood, right? 5B square is equal to A square means 5 divides A square. And the theorem states that if 5 divides A square, then what can we say? 5 divides A also. Clear? Keep this much in your mind. Now 5 divides A. That means 5 is a A. Inside A, 5 will be the multiple of A. That's the meaning. That means any number multiplied by 5 is A. It can be any number. Any number multiplied by 5 is A. That means inside A, or A belongs to the table of 5. That's the another meaning. In simple words, I'm just making you to understand that. Hope you understood, okay? So now, as you understood that 5 divides A square, we can write like this. Let A is equal to 5C, where C is any positive integer. We are taking C as an integer. So let A is equal to 5C, because A can be in the table of 5. That means A is a multiple of 5, because 5 divides A. That's why we can write A is equal to 5C, where C is any integer. Simply we are taking A, B, C like that, okay? Don't stick on that C. Why sir took this C? Don't think like that. Simply we are taking an integer. It's C. We are taking it, okay? C be any integer. Now A is equal to 5C. We wrote it. Now we got a value for A. What is it? 5C. What was the equation which we wrote right now? It is 5B square is equal to A square. So substitute the value of A inside that equation. When you are substituting the value, what you will get? 5B square is equal to 5C the whole square. That means 5B square is equal to 25C square, isn't it? Dividing both sides by 5, because 5 is common on both sides, cut off that 5, what you will get? Next step, B square is equal to 5C square. What does it mean? What does it mean? 5 divides B square, right? If 5 divides B square, by the theorem, what we can say? 5 divides B also. Now see, in the starting, I told you, before 3 or 4 steps, I just told you that 5 divides A. And now it's clearly understood that 5 divides B. What is the meaning of this one? That means 5 is a common factor of A and B. 5 is a common factor of A and B. Hope you got something, right? In the initial state, I told you something to remember. What was it? A and B is having only a common factor 1, right? But now we could understand that not only 1, 5 is also a common factor of A and B. That means A and B are not coprimes. They are having more than 1 common factors. If they are not coprimes, then we cannot write it as the form A by B. If you cannot write it as the form A by B, then that's what it called irrational number is. Clear? So we are coming to that point, okay? So anyhow, we got that 5 is a common factor of A and B. Next step we will write, this contradicts our assumption. right? This contradicts the statement that A and B are co-primes. It's coming a contradictory statement. It's just opposite of what we said in the initial part. This contradiction arises because of our assumption. That means what we have assumed, only because of that one we got this particular contradiction. That means our assumption is wrong. Now tell me, what did we assume? In the initial part of this question, we assumed that let root 5 be a rational number. That means that assumption is wrong. That is wrong. That means it's not rational. If it is not rational, then what would it be? It's irrational itself. That's how we have to prove. So finally we will say this contradiction arises because of our assumption that root 5 is rational. Therefore, root 5 is an irrational number, hence proved. This is the way how you have to prove this, and hope you understood. Okay students, so like this itself, if you're going to the next question and further questions also, this is the only way which you have to prove that. Well, let's go to the second question and understand how it is. Come on. What's the second question? Prove that 3 plus 2 root 5. Prove that 3 plus 2 root 5 is irrational. Starting with the same step, what we will write? Let us assume to the contradiction that 3 plus 2 root 5 is a rational number. Next line. There exist A and B such that 3 plus 2 root 5 is equal to A by B, where A and B are coprimes. So here see the LHS. It is 3 plus 2 root 5. In the LHS part, every time you keep this is the main thing which you have to remember in your mind. If you understood this, very fast you will come to the proof. See here, in the LHS part, what are the numbers? One is 3. Another one is 2 root 5. Among this, which is irrational? 2 root 5 is irrational. So keep the irrational number there and take the rational number and throw it to the RHS. That's the first step which you have. Every time you have to bring the LHS to an irrational number. Then you have to state that the RHS is rational. That's what we are going to do. So here 3 plus 2 root 5. That means keep the 2 root 5 there. Take the 3 to next side. What it will become? 2 root 5 is equal to A by B. This, when you are 3 taking and going to next side, what will happen? It will become minus 3. Now you got a 2 root 5 is equal to A by B minus 3. Taking LCM on the right hand side, what will become? It will become A minus 3B by B. Right? A minus 3B by B. Now you got a 2 root 5. So keep that root 5 there. Take this 2 also and take it to the, shift it to the right hand side. What will happen? Root 5 is equal to, now it becomes root 5 is equal to numerator part A minus 3B divided by, in the denominator this 2 will come here. So we will write A minus 3B divided by 2B. Clear? Now what is the RHS? Check out the RHS part. A minus 3B divided by 2B. In this RHS, A and B are positive integers, right? A and B are integers. So definitely if you're giving the values for A and B, if you're substituting the values for A and B, the RHS part is going to become a rational number anyhow, right? Because A and B are already integers. So if you're substituting the value for A and B, definitely what you are going to get? You will get that the RHS is an rational number, right? So we will write, as A and B are integers, the RHS part, that means A minus 3B by 2B will become a rational number, is a rational number. Therefore, what does it mean? The LHS, if the RHS is rational, then the LHS also should be rational, isn't it? Because LHS is equal to RHS. We are equating them, right? So definitely as you wrote equal to sign, that means whatever is there in the RHS, that is same as of the LHS. So here you got the RHS is a rational number. That means, next line, that means root 5 is a rational number. But this contradicts to the fact that root 5 is an irrational. We already know that root 5 is irrational. So this is contradiction to the statement which is well known. That means there is a contradiction. These two cannot be equal because already we know that root 5 is irrational. How can that be equal to an rational number? Never it can be. So what we will say? This contradiction, it arises due to our assumption that what was our assumption? 3 plus 2 root 5 is a rational number. That was the wrong thing which we chose. So finally we will write, therefore 3 plus 2 root 5 is irrational. Now to the next question. Prove that 1 by root 2 is irrational. This one is much more easier. It's quite easier because it's a small number, very fast you will get it. Okay, let's start it. Normally, as usual, how you will start? Let us assume to the contrary that 1 by root 2 is a rational number. We are taking that contradictory statement. Now, next line. There exist a and b such that 1 by root 2 is equal to a by b, where a and b are coprimes. Every time this will be the statement. Okay. Now we wrote it. What did we wrote? 1 by root 2 is equal to a by b. I told you in the LHS we have to bring only the rational number. What must we do to bring it to a rational number? Do one thing. Just take the reciprocal. So we will write taking the reciprocals on both sides. Root 2 is equal to b by a. Right? Root 2 is equal to b by a. Nothing more to do. What to do? Here root 2 is equal to b by a. And next line we will say, we are very near to the answer. Next line what will we say? B and a both are integers. Right? Both are integers. Therefore, the RHS or b by a, the value of b by a will be a rational number. Therefore, that implies, what does it mean? It implies the LHS. That means here the LHS is root 2. That implies root 2 is irrational. Root 2 is not irrational. We know it. This contradicts to the fact that root 2 is irrational. And this contradiction arises due to the assumption that 1 by root 2 is rational. That means our assumption was wrong. So finally we will conclude that therefore 1 by root 2 is irrational. Clear? Going to the next question. Prove that 7 root 5 is irrational. Very fast you can prove it, right? Because right now I hope that you understood the criteria how to go ahead to prove that a number is irrational. So come on, let us start it. What is the first step? Let us assume to the contrary that 7 root 5 is a rational number. Every time we will take like that. Next step. There exist a and b such that 7 root 5 is equal to a by b, where a and b are coprimes. Clear? We wrote it. Now, next step. So, 7 root 5 is equal to a by b. Keep that root 5 here, take that 7 and shift it to the RHS. So, next line what you will write? Root 5 is equal to a by, when 7 is going to the RHS, it will become divided. The numerator part will go to the denominator part. So, it will become root 5 is equal to a by 7b. Now, what about the RHS? As usual, we will say the same thing. Here, a and b are integers. Therefore, the RHS part, that means a by 7b, is a rational number. Means the value of a by 7b is a rational number. That means the LHS part, root 5, is also rational. We came to that conclusion. But, next line we will write, but this contradicts to the fact that root 5 is irrational. Means that's a fact which we already know. So it came to a contradiction. How can it be possible? So we will write, this is a contradictory statement to the fact which we know that root 5 is irrational. This contradiction arises due to our assumption that, what was our assumption? 7 root 5 is rational. Hence, 7 root 5 is irrational. Means we took it as rational and we got all this mesh. Right? So our assumption was wrong. What we have thought was wrong. So what we have thought was wrong means, what was the thing which we thought? We thought that, we imagined that 7 root 5 is irrational. I told you, if there is not rational, then that is irrational. So our assumption was 7 root 5 is rational. So if that assumption is wrong, what does it mean? It's not rational. It's not rational means it's irrational. So finally we will conclude that therefore 7 root 5 is irrational. Next question. Prove that 6 plus root 2 is an irrational number. Very fast you can do it, right? Because right now we have done at least 4 of sums and now you understood the criteria. Now you understood the technique how to bring it to a proven statement, right? So let us start with, as normal we will start, let us assume to the contrary that 6 plus root 2 is rational. What will be the next step? Yes, there exist a and b such that 6 plus root 2 is equal to a by b, where a and b are coprimes. Now 6 plus root 2, in the LHS 6 plus root 2. So keep only the root 2 there, take this 6 and put it into the RHS part. What it will become? Root 2 is equal to a by b minus 6 over. See the LHS, it's a irrational number. Whenever you are getting an irrational number in the LHS, stop it right there. That's enough for us. We are very near to our answer. Now just we have to explain that the RHS is rational and LHS is irrational. That's it. We are very near. So here when you are getting like this, right now what we got? Root 2 is equal to a by b minus 6. And now we will say as a and b are integers, the RHS a by b minus 6 will be a rational number. So now you got the RHS part. What is the RHS part? A by b minus 6. So what will we say? Here as a and b are integers, a by b minus 6 will be a rational number. Therefore, root 2, that means therefore, as the RHS is rational, then we will say therefore the LHS, that means what is the LHS here? Root 2. Therefore, root 2 is also a rational number. Next line we will say our doubt. What is the doubt? We will say, but this contradicts to the fact that root 2 is irrational. Which we already know that root 2 is irrational. How can somebody come and say that, oh, it's rational? It's not possible because it's a known fact. So that's what we are going to express here. We will say this contradicts to the statement, to the fact that root 2 is irrational. And this contradiction arises due to our assumption that, what was our assumption? Due to our assumption that 6 plus root 2 is rational. That means our assumption is wrong. Therefore, 6 plus root 2 is irrational. Hope you understood. See, this is the particular way how to prove that it's irrational. So, see, coming to this proof, if you are getting, I hope that right now, if you are getting any number, you can prove it. That irrational. What's the only thing which you have to understand in your mind? Every time whenever you are equating, first of all, just assume it as a rational number. Next step, equate it to a by b. What is the next step? What is the irrational part inside the given question? What is the irrational part inside the given question? You have to check out that one. You have to zoom that one. You have to understand that particular number and keep only that number on the LHS and take all the numbers which are there along with this number to the RHS part. And then finally you have to say, see this RHS. This RHS totally it is a rational number because a and b are integers. Then we will say it is rational. And if this is rational, then this LHS also should become rational. So we will say LHS is also rational. Then you will say no. We already know that that particular LHS, whatever it is, it may be root 7, root 5 or root 3, whatever it is, you will say that that given LHS, that thing which is under the root, that is already a known thing that it is a irrational. Then we will say this is a contradiction. And this contradiction arises due to our assumption. We have assumed something and that's what the problem came. Means our assumption is wrong. What was our assumption? We have assumed that the given question is a rational number. So our assumption is wrong. That means it's not rational. It's not rational means it's irrational. This is how you have to prove. If you understood this one, it's very nice. Very fast you can prove whatever question. Even though we are doing only some we are choosing only some examples, you can do right now, you can do any irrationality of number. You can prove any irrationality of any numbers. If there is an irrational number given in front of you, simply you can prove it just by this particular method.